Today we're going to learn about concentration within solutions and how there are different ways of describing concentration, and I'll just show you a quick instance of how concentration makes a difference. Here I have saturated saltwater solution, which has a relatively high concentration of sodium chloride in it, and then we have Gatorade, which has a much lower concentration of sodium chloride as well as some potassium chloride as well. Gatorade, ooh. Saturated salt water. Clearly this has a much higher concentration of ions and therefore allowed it to be a better electrolytic solution, conducting more electricity. Anyway, today, concentration is the amount of stuff and the amount of solid solution that you have, or the amount of space that the solution is taking up. And the ways we describe it are molarity, molality, mole fraction, mass percent, parts per million, parts per billion. All different ways to describe concentration, but they all have different purposes. For example, molarity, which is moles of solute per liter of solution, is useful when we're doing stoichiometry. If we're figuring out how many moles, we can easily calculate how many moles of something are present within a solution because we can measure the volume. If we have the molarity, we can calculate the number of moles, and therefore calculate the amount of moles we need to react with something else, or how many moles of product we can make from it. Molality we use it for colligative properties such as boiling point elevation and freezing point depression, because when you have a solute dissolved in a solution or in a solvent, the higher the concentration is, the more it impacts those properties. So how it impacts the boiling point? First off, the boiling point is the temperature at which the vapor pressure of a solution is equal to the atmospheric pressure pushing down. So within a solution of pure water, all of the water molecules will be pushing upward, and when they have enough force to overcome the atmospheric pressure pushing down on it, it will boil. However, if some of the surface of your solution is occupied by something that doesn't really evaporate, such as like antifreeze or something like that, those molecules will get in the way and reduce the amount of upward force at the surface of the liquid, lowering the vapor pressure and thus requiring a higher temperature for the molecules at the surface to overcome the atmospheric pressure that's present. It also can impact the temperature that water freezes at, and that's why we put calcium chloride on the roads or salt to prevent ice from forming and to melt ice. What happens is when water freezes, the hydrogen bonds in the molecules between molecules become static, holding them in place and forming a solid ice. However, if you have a substance or a particle that's interfering with those hydrogen bonds, it requires a much lower temperature. It lets the molecules move more slowly in order for those permanent locks to hold in place, thus lowering the freezing point. Mole fraction we use when we're using Raoult's law, which we'll make a separate video for, which allows us to determine the amount of vapor pressure you would have in a solution that's not just a pure liquid. And then mass percent we use just basically describing the mass of a substance and the mass of a whole solution. And when we're talking about trace amounts of a solute, such as if you were doing water testing, you'd be looking at either parts per million or parts per billion, where you're looking at micrograms of solute per liter of solution or nanograms of solute per liter of solution. And that's when you're looking at trace things. Like if you were doing pool testing, you're looking for chlorine concentration in your water, would probably be parts per million, and then parts per billion would be like if you were looking, hopefully parts per billion, if you were looking at the amount of arsenic in your drinking water. So each of these types of concentration calculations have a purpose, and we'll go over each one individually in subsequent videos.